So, ooh, we should probably do that whole attendance thing, considering how many bodies are missing. That one's here, that one's here, that one's here, that one's there. That one's here, gone, here, gone. Here, here, here. Of course, gone. That's kind of standard now. Here, here, and here. Cool. Okay. A. I didn't send out the text. Don't bother asking if I've got the grades in, because as soon as I have them in, I send you the text. I haven't sent the text. Ergo, not graded. Because Thursday, Friday, back-to-back game club tournaments in the library, all-day thing. And then we had family visiting. I didn't touch anything school-related for the last 4 days, and I hope you didn't either. B. I said we lost our phones. That also includes our headphones. Let's make sure those are gone, particularly for those of us who did not deign to watch our lesson videos when we were actually supposed to. C. Everyone got your notes? Okay. After seeing what was and was not attempted as I went through books again, tell you what, for the rest of the semester, I'm just going to go for it. I'm just going to keep going. If you did it, you did it. And you're going to be able to keep up. If you didn't, you're not going to be able to keep up, and you're going to drown behind the bus. Okay? So, did anyone bother to actually do this? Look at it, think about it, talk to your neighbor, ask a question? Anything? Cool, freshman class. Oh, hi.
Well, so there's programming for the graphs, we just take the 7 times 4.
Okay. When they say, here's X and a Y, and you have labels, then they told you what it meant. So roll with it. 7 of those. So it's 7 ounces. Ooh, you can't even see that. Here, let's get something better. You, dark blue. So it's 7 ounces of cashews. Okay, well, it says cashews have 4 grams per protein, you said. So 7 of those, and we're going to have 7 grams protein per the peanuts. Those are our Y's. So if there's 4 of those, take that by 7. 28 and 28 total, 56. Okay, but the points on them, we have to keep remembering that it's not just random numbers thrown on a graph. When they label their axes, they are telling you that every x, y is going to represent the amount of cashews and the amount of peanuts. Labeling axes, labeling things in a problem, labeling things in terms of the words, it tells you what the numbers mean. They're not just random numbers we're pulling out of an orifice and saying, here, play with these. They mean something. Now, you called it, take the 4 times the 7, take the 7 times the 4, because those are rates. And that's actually going to come into play today with our third form of linear equations. We wrote out that there's a word problem version of our other forms. So maybe we need to remember, what are our other forms? What are the 2 forms we've dealt with so far? Slope intercept. So what does slope intercept form look like? Okay, and then in terms of its words, y equals rate x plus start. Okay? These are your tennis shoes, your comfortable walking shoes. These are the ones you want to spend 90% of your time in. The other ones got value, though. You're probably not wearing your tennis shoes to Aunt Kathy's funeral. You're probably not wearing them to Snowball. You're going to wear the shiny ones, the fancy ones, right? Okay, I'm probably not wearing my regular tennis shoes when I'm slopping around out in the yard and I'm feeding the cows. I want something that's got a little more, well, first of all, ankle to it, so we don't get a bunch of crap stuck in our socks. But they each have a purpose. Slope Intercept is really good for graphing. Perfect for graphing. If I was going to write it out as its kind of more detailed version, remember slope was rise and run. Run was always to the right, rise. If it's positive, we head up. If it's negative, we head down. Like that. And then our y-intercept was always the coordinate 0, b. But this, in terms of words, what was the other one that we spent some time on? Okay. Point slope. They're not named very originally. They don't have fancy names. You know, it's like, name your team for the math competition. We're the number crunchers. Ugh. Like really lame kind of naming, right? Point slope, they call it that because they give you a point and a slope. I'll have y minus y1 is m times x minus x1. Where we had to be careful about these, here, is there was a number here and here. There's going to be a number here, here, and here. The y and the x always stay the same because that's where you get to plug stuff in. These were really nice when I had the slope and it went through the coordinate x1, y1. And as we found out, if we were given more than 1 point, well, we can use different coordinates on there. You can actually have the same line have 50 different equations if you've got 50 different coordinates. In terms of words, y minus the, do you remember? Or have it written down in the notes in front of you? How did this work in word problem land? Because the information they give you in the word problem determines which of these three formats you're going to use. I don't want to reinvent the wheel to make slope intercept form if they gave me this stuff. Okay, so they're going to give me not a starting amount. Well, it might be, but most of the time it isn't. They're going to give me an output or a result, then a rate and a input. So here's the difference in the wording. The population of spearfish is currently 15,381. Every year, the population goes up by about 400 people. Starting amount, rate. Here, they would say every year the population of spearfish goes up by 400 people. In 2014, there were 14,972. They gave you, in this year, there were this many. They gave you a coordinate. Input, year, output, number of people. Okay? So point slope form is really good for that. What we're getting today, new kid on the block, is called standard form. Standard form is AX plus BY equals C. It's written like a middle school dance. Boys over here, girls over there, everyone look at each other awkwardly. The variables will be on one side. The constant that doesn't have a variable will be on the other side. So an example of it would be something like 3x plus 4y equals 12. That's standard form. And you're going to see that throughout algebra. Standard form is usually all of the variable stuff here equal to, and then they like to set things equal to 0 later so that they can solve. This one, in terms of word problems, just like that opening example, you're going to have a rate for whatever the first thing is you're talking about, a rate for whatever the second thing is you're talking about, and it's going to equal a total. Kind of ran out of room there. Rate x, rate y equals total. That's what sets it apart in word problems. They're going to say, I spent $120 on clothes for back to school. It was all at one place. All of the jeans cost 20 bucks and all of the shirts cost 15 bucks. How many of each did I buy? 20 was a rate for one thing, 15 is a rate for another. They gave us a total. 20x plus 15y equals 120. Okay? So we need to have this for sure written down right at the bottom here where they give us that form. They tell us our standard form looky like this. Rate x plus rate y equals total. That's how they're going to give this to us. They really like this for giving us totals. When they tell you you went on a total of 15 rides at the park, that the team spent a total of 1,500 bucks on equipment, that's going to be standard form. It's the only one that gives us total. Okay? So, the nice part about it is it's really easy to do x and y intercepts. You can actually do really quick graphs out of these without rearranging them. Okay, side quest over in this corner. If I told you to graph this right now, what is your current instinct? Well, I don't know how to graph it if it looks like that, so I'm gonna move stuff around, right? You would have said minus 3x, for y is negative 3x plus 24. Divide everything by 4. Making sure that we don't divide like freshmen, divide all of them by 4. Remember, math is communist. What you do for one, you do for all. Then you'd be okay graphing it. Start at 6, slope is down 3, right 4. What if I told you you didn't have to do that? You are going to say, start at 6, down 3, right 4. Down 3, right 4. Like so. Whereas I'm going to come up to it and say, my y-intercept is going to be at 8. Or sorry, 6. My x-intercept is going to be at 8. Connect those two dots and I'm done. Like, whoa, that sounded faster. So here's how it works. To find an x-intercept, you plug 0 in for y. Because everything on this x-axis, they've all got coordinates of something 0, something 0, something 0, something 0. Everything on the x-axis has something comma 0. So if I want to know where it hits the x-axis, put a 0 in for y and solve. Now, the formal version of it says I'll actually take 3x plus 4 and plug a 0 in. But what's anything times 20, or 0? 0. But, so it's just 3x is 24. Divide. There's x-intercept at 8. Now, I don't have to go through all this step. Could you just cover that up? Because anything times 0 is 0. So this term is just going to disappear. Can you divide 24 by 3 in your head? So I would do that. You don't have to write it out. If you can go straight for the throat and cover up the y, divide, and say x-intercept is at 8. So see if you can extrapolate that. What do you think we're going to do to find the y-intercept? Look at what we did to find x-intercept. Put a 0 in for x instead. Because you look at that graph, everything on the y-axis is something, 0 comma something. 0 comma something. 0 comma something. Every one of the y-intercepts is 0 something. The x was 0. So if I want to know what my y-intercept is, I'm going to plug 0 in for x. And just like before, I could say 3 by something plus 4y is 24 and plug in my 0. But anything times 0 is 0. So I don't need to go through writing it down if you are okay with cover up the x and divide. Right? Divide, and I'll get a y-intercept of 6. That's what I mean by instead of all of this stuff. You don't need all of it if you can just cover this up, divide 8. Cover this up, divide 6. Mark 8 and 6 as your x and y intercepts. Connect the dots, you're done. Fast. Standard form is really good for some word problems and really good for some quick graphs. So these don't actually ask you to graph it. That comes next. Can you do the finger trick and just tell me what the x and y intercepts are? Go. Okay, x-intercept, put a 0 in for y. Y-intercept, put a 0 in for x. If you want to find one, get rid of the other. One thing I'm going to caution you about, if it's not a terminating decimal, don't write it as a decimal, write it as the fraction. Remember, if it's 4/3, I don't write 1.3. I actually leave it as 4/3. Because otherwise you lost part of your answer. But if it's a terminating decimal, like 2.5, go ahead and write 2.5. I'm okay with that. when you write these, I'm going to give you a little bit of a caution. Don't just write x equals y equals. Actually write at least x int equals y int equals. Because something else we're going to do with these today is x equals and y equals graphs look a special certain way. Okay? So don't just say x equals 3, because that's a whole vertical line at 3. If you're saying the x-intercept is 3, then make sure you just say, okay, you can have zint and yint. It's still not a lot of writing. Okay? So if I'm going to find the x-intercept, then I put a 0 in for y, and it becomes 0. And I can mental math my way through that and say, if 5x equals 60, divide by 5, x-intercept is who? You're scaring me there. If I want the y-intercept, I put a 0 in for x. Careful, see where I put the 0. The negative is still with that 6y. So 60 divided by negative 6. If you just got caught in that trap, I'd recommend a note to yourself. All the way back to first semester when we were doing combining like terms, remember every time you run into a plus or a minus, it's a new term? We would chop it up like this. Would that help when you cover up the x term, remembering that the negative stays there? Okay. Chop it up every time I see a plus or a minus. X-intercept, 0 goes in here, divide by 3. X-intercept is 4. Y-intercept, cover this term up. It's a positive 8 that I'm dividing by. And I will get either 1.5 or 3 halves. Because 1.5 is a terminating decimal, I'll take both. Your preference. Okay? Now the reason we start with that, and we practice that at the beginning, is because then we go to make the graphs. See, before you would have had to rearrange this to get slope-intercept form. You don't got to do it anymore. Now you get these quick graphs. You're not going to have only two, you're not going to have 3, 4, 5 points, but if you trust your math, well, start with, put a 0 in for y, x-intercept. 1x is negative 2. My x-intercept is negative 2. So I mark negative 2 on my x-axis. If I want a y-intercept, I plug 0 in for x. Negative 2y equals negative 2. Divide. Y is 1. I get a y-intercept of 1. Now, I only have 2 points. Those are the only 2 that I need. I can make more because now I see a slope to them. From here to here, it went up 1, right 2. So I can use that up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2, to make a few more points to be sure that my line doesn't suck. Like, I don't know if any of you, especially, here in South Dakota, do any shooting. The difference between a 12-inch barrel versus an 18-inch barrel, okay? At the very least, you play games. The difference between I want to hit that guy 100 yards away and all I got is a pistol versus I have an actual rifle, right? One is more accurate than the other. Well, if these 2 points are real close together, that's a very short barrel. It's not going to be very accurate. But if I have 2 points that are very far apart, that's a very long barrel. I'm going to have a very accurate line. Okay? So that's why I made some more points. These two were a little too close together for my liking. They're easy to find, but I'm going to make a few more just to be safe. Connect the dots, use a straight edge, try not to suck. Oh, another thing, going through the notebooks. Y'all, I told you at the beginning of the semester, we're halfway through it now. Get graph paper. Okay? That an assignment full of this doesn't count. Okay, that is not you graphed it. That's you sketch something that kind of looks like it. All right, at the very least, there's always a stack of graph paper up there above the calculators, so you can just grab a sheet at a time. Or instead of buying 3-4 Pop-Tarts in a week, maybe drop $1 in there and grab a graph paper notebook. You're set for the year. Okay? I usually buy a couple boxes from Walmart and then just, that way kids don't have to go make a special trip for them. So, you start with the equation, do the whole cover this, cover that, make your two x and y intercepts, connect the dots. If you need to rearrange it to confirm that you're right, okay. If you need to write down the steps to make your x and y intercepts, okay. If you need to make more points so that your line isn't trash, also okay. Come by, I just saw 2 of us are already changing our scale. Sometimes you gotta do that. Always find your intercepts first, then start graphing. Okay, even if you are going to write work, it doesn't take a lot. Plug in 0, solve for the thing that's left. X is the only thing that's left, so clearly this would be a x-intercept. But if it's at 10 and I only got 5 boxes, that ain't going to work. So I will change my scale and make my x-axis go by 2s. Now I'm at 2, 4, 6, 8, 10. I don't have to change my y-axis if that was fine. So I can leave that going by 1s. Y-intercept, 1, 2, 3, 4. Connect the dots. Because I'm up here on giant smartboard, I'm actually going to make one more point in between so that I've got a little something to aim at. Like that. Okay. Oh, another thing. Most of you are good about this. There's only a handful that do it. See how my graphs always, or my lines always go off the graph? I'm showing you this continues past just what I see. The number of times that I see this, and that's it, okay, actually takes more effort to quit than it does to just swipe the line through the whole graph. All right, keep it going all the way through. How do we feel about this so far? Like, cover it up, divide, divide, poke, poke, done? It should be fairly easy. Okay, these lend themselves to quick graphs. But what if they're not so nice? Hi.
So when you cover up,
Oh.
so when you cover up X, you're looking for Y. When you cover up Y, you're looking for X.
Yep, because that's the only letter that's left. It's the only variable that's still there. What if it doesn't come out nice? Sneaky, sneaky. I want to see on 6 and 12, except I'm going to change 12 a little bit. Try 6 and 12, because now they're getting a little ugly. Can you still do it when it starts getting a little ugly? Remember what we said about the whole fraction decimal thing. If it's a terminating decimal and you can write the entire decimal, okay. But if you can't, you better leave it in fraction town. There you go. Get those calculators out. Let them do the work for you. Be very careful that you are dividing the correct direction. Okay. 11 halves, not 2 elevenths. I put a 0 in for y. Divide 11 by negative 2, I get an x-intercept of negative 11 halves or negative 5.5. I'll take either because it was terminating. Y-intercept. If I put a 0 in for x and divide 11 by 7, it just has to stay 11 sevenths. Okay. That's what's called a repeating decimal. What was it? 11 sevenths, isn't it? Like 0.63636363? I remember it alternates. Oh, 11 sevens. I'm thinking 7/11. See? Double check it in the calculator. Make sure it does work for you. Oh, God, no. If you're doing by sevens, there's butt ugly pattern to this. Like, it's almost no pattern. I don't know how many of you can actually arrow out on your decimals. Can you actually see where it starts repeating? Sevenths are ridiculous. It's something like 20 digits out there. And then it starts repeating itself. But, okay. So I'll just leave them like that and be happy. All right, x-intercept. Again, I plug a 0 in and get negative 14 over 2, or sorry, over 4. Reduce it, divide by 2, divide by 2, 2. So you could have said I either have a x-intercept at negative 7 halves or negative 3.5. I'll take either one. Or a y-intercept. Again, put a 0 in for x and divide. That's a negative 14 divided by a negative 12. Divide both by a negative 2, getting 7/6. I hate the word sixths. There's too many consonants. Okay, so I just got to leave it like that because I can't turn that into a decimal. So 7/6. 1 and a 6, right about meow. Negative 3.5. Right about meow. Do I got enough to put a ruler on that and connect the dots? Did I? Yeah, I did. I said y and then x instead of x and then y. So you go here, x-intercept negative 3.5, y-intercept of, there we go. Yes, it is. Would you be able to make some more points with it?
Yeah.
Right? I mean, it'd be kind of ballparked, but you could. I go up about 7/6 over 3.5, go up 7/6 over 3.5. That's ballpark. 97 goes bye-bye. Connect the dots and you're good to go, right? That's all there is to it. Is it still in my pocket? It's still in my pocket. Yep. Oh, that's blue. We don't want blue. I'll find the other one later. Okay. Okay. The graphs for them are special. I'll tell you, all the way up into Algebra 2, these are usually well, until you review it. These are the equations that kids screw up the most when they're graphing because they expect it to be a lot more complicated. Where's the y? You don't get one. There's nothing. So how can I put it in y equals mx plus b if there isn't a y at all? Okay, I can't put it in point slope form if there isn't a y at all. I can't put it in standard form. Oh wait, this is standard form. This is 1x plus 0y equals 3. We just simplified it down. So where's my x-intercept? 3. Where's my y-intercept? Divide. Error, right? 3 divided by 0, you can't do that. So it never hits the y-axis. Because, think about this in a table. This is like I am Groot for math. If y was negative 2, x is still 3. It doesn't matter what y is. If y was negative 1, I am Groot. If y was 0, I am Groot. If y was 5, I am Groot. No matter what. So what does it look like when all of them end up like this? It's a vertical line. So right next to this, maybe write the table to help yourself remember. But if you ever see x equals number, it's a vertical line at that number, and the slope is undefined. X equals 3 is just vertical line at 3 and nothing else. Super easy to do, but you know how many kids will go and put a dot at 3 and then they'll try to do a slope of 1? Most common error. I don't know why they think it's a slope of 1 now. Because there's a 1 in front of the x? I don't know. But they just come up with something. Because they expect it to be more complicated than that when really that's all it is. The y's, very similar. This is a real fancy version of 0x plus 1y is 3. Where's my x-intercept?
3. I mean 0, sorry.
Y-intercept is 3. What about that x-intercept? Remember what you're dividing. Undefined again. It's never going to hit the x-axis. Maybe another way to write this would be y equals 0x plus 3. Y equals mx plus b. Y'all know what 0 slope looks like? No rise, just run. Because again, in that table, if x is negative 2, I am Groot. X is negative 1, I am Groot. X is 1, I am Groot. X is 4, I am Groot. It doesn't care. Y is always 3. So if I make those points, negative 2, 3, negative 1, 3, 0, 3 I already had, 1, 3, 4, 3, that's a 3, 3. Here, 4, 3. I get a horizontal line. So go ahead and write that note to yourself too if you ever see y equals a number. It's a horizontal line and the slope is 0. They're super easy to graph. Very, very easy to graph. So, got 4 of them. Said they're not difficult. Graph them all. X's are vertical lines, Y's are horizontal lines at those numbers. Okay, looks like y'all get it. It's not very tough. X equals number, vertical line. X equals 4, put the vertical line at 4. X equals negative 1, put the vertical line at negative 1. Y equals 0, horizontal line, put it at 0. Horizontal line, put it at 1. Done. That's it. Okay. Riddle me this. What would it look like if I graphed y equals 2 and x equals 3 on the same coordinate plane? What would it look like? Both lines on the same graph. Yeah, it'd be a T, right? X equals number, Y equals number, bam. Where would they cross? Please tell me you remember someone showing you that when you first learned about these coordinate planes, that this is two number lines stacked on top of each other. This is the number line from -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. And then we had another number line for a different variable. Well, this one's already going this way, so they took that number line and moved it this way. Slapped it on there. That's why you have all of these boxes intersecting, is when I say x equals 3 and y equals 2, x is 3, y is 2, the place that they meet is the coordinate 3, 2. And then we just started using shorthand notation for that. That's what a coordinate pair is. It's shorthand notation for these two lines when they cross. The line crosses the line at the place. Fairly simple concept. Remember that for chapter 6. Because what happens when I start doing things like this? Okay. All of chapter 6 is systems of equations. We have to know this stuff down cold because in chapter 6 we're going to have 2 of them on one graph, maybe 3. And you have to say, where do they all cross? Because that's the only place where they're all going to be true. Okay? We're almost there. Real quick, the vertical horizontal thing, we cool? Pretty, okay, not bad. The last, semi-last, because there's always word problems, right? Is write this in standard form using integers. Do you remember what integers are? Do we have our notes from first semester? Do we have our notes from sections 1, 2, I think? Okay. You should have had something that was like, here's all of my natural numbers. We call those Alabama math. Counting on your fingers and toes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20, 21. And then you had whole numbers. Whole numbers also include 0. And then we had integers. Integers include all of that, and it's -3, -2, -1, 0, 1, 2, 3. It's positive and negative whole numbers. Meaning, when they say using integers, maybe this would be a little easier for you. Off to the side, you write no fractions or decimals allowed. Like old school Little Rascals. No girls allowed. And then they usually get beat in the race anyway. Okay. Using integers means at the end of this, I'm not allowed to have any fractions. Standard form tells me I need to make it look like this. So I've got 2 things I got to do. 1, variables over here, constants over there. Who's got to move? Who's on the wrong side? The x. I need the y and the x on the same side. I suppose you could have brought the y over here and then moved the 5 over there, but yeah. Same difference. So stage 1, I'm going to add 3/7 x. I also know that some of us are lost without that little dividing line down there to make sure we don't accidentally screw up. That zeroes out and I just get 5. Cool. Our x and y like terms. They don't go together. Can't mate a turtle and a giraffe. Fun to watch, doesn't accomplish anything. So you just put those two together. Spring break 2004, we went down to Arizona to visit some friends. We went to the zoo. The turtle was trying to climb over the giraffe's leg to get onto the other side of the log. It looked like it was trying to hump its leg. It made its way into my examples for the next 18 years. Okay. So it looked like, and like, that's an ambitious turtle right there. Right now, I've got it in standard form. This is actually standard form. I could get my x and y intercepts right now. Put a 0 in, put a 0 in, divide, divide, you're good. You'd have some fractions, it's okay. But it says integers and standard form. So I'm not allowed to have fractions. 3/7 is a fraction. How do I make it not 3/7? How do I make it not a fraction anymore? Yes, math. If I don't want half a pizza, I want a whole pizza. What do I need to do? I double it. I need more pizza. If I have something in sevenths, I don't want sevenths. I want whole thing. Multiply the whole honkin' equation by whatever that denominator is. So now, 3/7 times 7. The 7s will cancel. I'll just get 3x. Make sure to keep going though. 7 times y is 7y. 7 times 5 is 35. Now, I'm in standard form, x's and y's here, constant over there, and there's no more fractions or decimals. Integers only. Okay? This skill right here of I don't want fractions, so just multiply everything by whatever that denominator is. Do you remember that from first semester? If you ever had an equation that had fractions in it, just say, screw it, I don't want to work with fractions. Multiply by whatever the denominator is, bam, I have no fractions. Think back to your first quiz of the semester in here. What happens if I have something like 3/5 x minus 2/3 plus 6/5 x equals 18? What if I just gave that to you right now and said, solve it? If you get this right, you get to eliminate a question on your next test. How many of us would absolutely just crap our pants because there's fractions? But I don't like fractions. They're evil. Make them go away. Could you take this whole honkin' thing times a number and it would make those fractions go away? Not just 5, because there's also a 3 here. Not just 3, because there's also 5s there. I would use 15. The common denominator between them. 3/5 of 15. 9. 2/3 of 15. 10. 6/5 of 15. Oh, wait. Got to get the other side. Always better if you do your arrows. 15 by 18. Does anyone know off the top of their head?
No. 270.
Okay. go on to Algebra 1, we show you we do foiling. It's double distribution. You can do that with 15 and 18. Call it 10 plus 5 times 10 plus 8. That's how I do them in my head. 180, 50 is 230, plus another 40 is 270. It's just a way to organize how you multiply. Combined like terms, I'd get 27x minus 10 is 270. 27x is 280. Divide, x is 280 over 27, and unfortunately that does not simplify at all. How annoying would it have been to do that with common denominators and then moving stuff around, adding and subtracting by common denominators, multiplying by the reciprocal, when instead you can just say, I don't like fractions. Multiply everything, make them go away. That is a handy skill to have. And that is what I'm asking you to do here. I want you to rearrange this feller. Ooh, it's in point slope form. So start by distributing, and then you can either move things around as is, and then get rid of the fraction, or could get rid of the fraction right there. You can get rid of the fraction right now if you know what to multiply by. What's up?
That do that right.
1 x 5 2. Let's see, 5. Oh, yeah.
Okay.
The standard form of this thing actually comes out very clean. I'm going to do it 3 ways so you can see, just get a feel for it. Which way do you think is better? Stage 1, the brute force way that most of the book is going to tell us. I start with distribution. Then I would need to get all of my constants to one side. But when I do, that just kind of makes stuff disappear. Right? 0 and 0. Then I would add 1/3 x. Not the same kind of critter, so they're just going to stand next to each other and be awkward. Getting 0. It's in standard form, but it's not integer coefficients. So I would finish it off by multiply the whole honking thing by 3. Times 3, it's just an x. Times 3, now it's a 3y. Times 3, it's still a 0. And I'm done. Option 2 says I'll still distribute, but maybe right here I decide I don't like fractions. I don't want to move anything until that fraction's gone. You can do that. Take the whole honking thing times 3, getting 3y minus 6 is negative x minus 6. And then move stuff. I hope that some of you came out of first semester being able to do stuff like this. Double dose. Some kids like it, some kids hate it. Some would rather do one thing at a time. Some kids are like, yeah, that's fine. Okay, it all depends. It really is your jam. But zeros out, zeros out. X plus 3y is left. Zeros out, zeros out. Well, that's just 0. Same thing I had. So option 1, distribute, move stuff around, get rid of the fraction. Option 2, distribute, get rid of fraction, then move stuff around. Option 3, you have to be more careful with this. I could take the whole thing times 3 right now. But when I do, I got to be very, very careful. 3 times y, 3 times negative 2, 3 times negative a third is just negative 1. What if I had done a negative 3? What if I had just said, I want to get rid of this? That would have been a negative 3y, a positive 6. Now this is nothing, and I would just have x plus 6. This is what I mean about you got to be careful. When I distribute into this side, see how these two are smashed together? If they're smashed together right now, that means they're a single term. So I can't distribute into the 6 because there's already a set of parentheses there. Kind of like you probably shouldn't multiply with someone who's already multiplying with someone else. Okay? Gets awkward. And then, well, if I subtract 6 from both sides, I'll just add 3y on the other side. Same difference. There you go. So I just want to show you, look how there were progressively fewer and fewer steps, but there was more thinking. The more thinking you do, the less you have to write. The more writing you do, the less you have to think. And it is a trade-off. It is your personal preference. All 3 of these follow math law. Now, I know that we need practice with that. I know we need practice with it. So, 21 to 24 at the bottom. I want you to do all 4 of them. All 4 of them at the bottom. We need the practice. I'll get started on that.
Negative x plus y, or
Yes.
okay.
Just move stuff around. And spent all the first semester on this. Distribute if you have to. Add the thing, subtract the thing, multiply the thing. As long as you follow math law and get here by the end of it, I don't care. Follow math law, end up there. Okay, who's got to move? X's and Y's got to be over here. Plain numbers got to be over there. All four, not just one or two, and yeah, I kind of get it and ignore it. Who's got to move? You know, first semester I had a few kids who were just absolutely in love with that dividing line. If you need this to remind yourself which side is which, so that you're always doing the same thing to both sides, not a bad idea. My Algebra 1 crew, I got about 4 or 5 kids that as soon as they started doing that, they started acing tests. That just was the thing that made the difference for them. If you need it, use it. If you don't, don't. Someone left a book in my room last semester. I don't remember who did it.
It goes to the next door.
You know, the books are modal. Got multiple, like, uses. Use number 238B. Spike a ball. That works. We're getting all new books next year. These are all going to be bonfire. Use number 23A. Keep your table up. They got all kinds. Curious. Both of these are super fast. The corner ones here. Subtract, not X, not 6. It's an X. Okay. We would subtract X, and we're already done. Negative X plus Y is negative 4. What's its X-intercept? That should be mental math by now. Put a 0 in for Y. Divide by negative 1. X-intercept is 4. Y-intercept is... Okay. The other one, very similar. Start by adding 3/5 X. This is, in standard form, it doesn't have integers yet. Fractions are evil. I don't like them. Make them go away. Multiply the whole honking thing by 5. Get 3x, 5y, and 10. How many of us missed the and 10? Left it as a 2. Okay. It's a very common error. I recommend you use those arrows as you're distributing something to force yourself to do each and every one of them. Contestants 2 and 3, I need to start by distributing. In both cases, I saw some of you kind of give me the, I just smelled a fart when I did two things at once, so I'll do them separately. Constants over here. Constants over here. Oh, no. New color. Make sure you have your y is negative 3x minus 9. So it's actually going to kind of pit stop at slope-intercept form. But it ain't done yet. Variables on the left. Add 3x to both sides. Subtract 5x from both sides. See how when you get these into standard form, you never know where your negative is going to show up, but always put your x first. Okay, that's what standard form is, x then y. It's going to be important when we do, I think we're introducing you to 3 variable systems this year. Not 100% sure. Got to ask Jameson what he did with Algebra 1. What? Did I do a goof?
No, just the way she had them written.
Oh.
You said it's X and Y.
Yeah, x then y.
She has a Y and X.
Ah. Standard form.
Doesn't necessarily matter.
They're still algebraically the same thing. It's just a different form. Superman is wearing underwear? He's just wearing them on the outside? Okay. Hmm, I personally don't have an issue with it. I know that some other teachers do. I don't care. I would give you full credit for that on test. But there are some, there's some teachers and some textbooks that will go even further. They'll go even further. This one, 7.05, 3x minus y was -9, right? Right, -3 minus 6, yeah. They'll say that this is standard form. But that isn't. There are some textbooks and some teachers, usually ones who still think it's 1987, that say not only do you have to have integer coefficients, you're not allowed to lead with a negative. And I've seen some teachers take points off for that. Our old algebra half teacher, retired a couple years ago, Mr. Schroeder, he was very much a stickler about that. He said you had to start with positive or else. Notice I said the guy who retired thought that was important. Because it's not 1987 anymore. Okay? The words. Y'all wrote down that little cheater form at the beginning, right? Rate x plus rate y equals what? Total. Okay? So, if I know that the rate that goes with this stuff and the rate that goes with that stuff, they'll each have one separately, is my total. Let's hunt it down. Oh, gross. Okay. Boy, this is old textbook. A media download store sells songs for $1 each and movies for $12 each. Okay, this would be like old school, like circa 2005 iTunes, Napster. You have $60 to spend, you want to buy a bunch of stuff. What up here was a rate and what was a total? 60 was a total, so do that. Well, how do I know which one's which, right? The very first thing we should do before starting to write an equation is we should define our variables. It doesn't have any special thing in there. It doesn't say where D is number of downloads, where M is number of music. It doesn't say anything like that, so you get to choose. What are the two things you're talking about? Songs and movies. So you can just label them however you want. Do you want to do songs and movies or movies and songs? All right. So I'll say X and Y are going to be songs and movies. That should be the very first thing you do. Because now I know what the crap I'm talking about. And then, since it's rate X, now I search for what is the rate that goes with songs. It's 1x plus rate Y, the the rate that goes with movies, 12y. So yeah, it was going to be x plus 12y, but now I have it labeled. Now I know what it actually means, what matters. Okay. What are 3 combinations of numbers of songs and movies that you can purchase? Well, I got the equation. I need to graph it. To graph it, have you put a little note over here to graph? Find your intercepts first. Int first, not if turnst. So start by finding what your intercepts are going to be. Shove a 0 in for y, x-intercept is going to be 60. Shove a 0 in for x. Divide by 12. Get a y-intercept of what? 5. The reason I said that is you need to fit it on the graph. How many boxes do I got at the bottom there? I need to go out to an x-intercept of 60. What should I probably be going by? I could go by 10s and fit it. Could I go by 5s and fit it? Not quite. Could I go by 6s? Yeah? So you get a choice, right? It just has to be accurate. I like the idea of going by 10s because you can still see a little more of the graph. So let's do that and label accordingly. We said X was number of songs purchased. And we said 10, 20, 30, 40, 50, 60. Y was our number of movies. I need to go up to at least 5. Do I got enough room?
Yeah.
Okay, so I'll just go by ones. Movies purchased. I found my x and y intercepts, makes my graph a lot easier. X-intercept of 60, y-intercept of 5, connect the dots. Now, unfortunately, I don't see a nice, easy integer intersection that those go through. So to answer this last question, I might have to do some thinking. What are 3 combinations of numbers of songs and movies you can purchase? It doesn't make a lot of sense for me to put in there, I'll do 17 songs and then go find out how many movies. 60 minus 17 is 43. 43 divided by 12 is not a whole movie. It wouldn't make sense for me to do that. So I'd rather put in numbers for the movies first. If I put in 0 movies, we said there was 60 songs. What if I put in 1 movie? So that's 12, subtract, and yes, 48. What if I did 2 movies? 2 by 12 is 24, subtract. 3 movies, 24. And you would keep going until you hit what? 0. Until I hit 5 movies and 0 songs. It asks what are 3 combinations. I don't need to list them all. I just need to write some that work. Okay? So if they switched it up to 15 for each movie, you'd be cool with just swap the 12 out for a 15 and you're good to go? So you better know how to graph something by now. I want to know, can you write the equation? Write that equation in standard form. You better be able to graph it. That was the first half of the semester. Rate x plus rate y is your total. So I would always start by finding my total. Ask what are the two things we're talking about? Okay, what's the rate for thing one? What's the rate for thing two? First thing you should be doing is labeling what you're talking about. What are the two things you're talking about? Okay, label them. What's a nickel worth? Oh wait, it's total cents. So yeah. 5x, dimes are 10y, total 5.95. There you go. Yep. Which is why change jars are so heavy and not worth much.
Again,